This video deals with the topic undefined algebraic fractions. Now, a fraction or an algebraic fraction is undefined when it has a non-zero numerator and a denominator value equal to 0. So a fraction a over b is undefined if b is 0. So let's do it this way. It's undefined when b equals 0 and a is not equal to 0, where a and b represent real numbers. So a fraction is undefined when it has a non-zero numerator. So the numerator of this fraction, a, is non-zero, is not equal to 0. Non-zero, not equal to 0. And the denominator value equal to 0. b equals 0. So for a fraction to be undefined, its denominator has to be equal to 0 and its numerator must be non-zero. That's all you need to know. So we can go and try some examples out now. This example question asks us to determine the value of x that causes the algebraic fraction below to be undefined. It's telling us to determine the value of x which causes this algebraic fraction to be undefined. So let's go back to the basics. A fraction is undefined when its denominator is equal to 0 and when its numerator is not equal to 0. In this fraction, our numerator is 1, which isn't equal to 0, so we pass one of the conditions. The other condition is that the denominator must be equal to 0, which means this fraction is undefined when x plus 3 is equal to 0. Therefore, this fraction is undefined when x is equal to minus 3, because if I make x the subject of this equation, I get x equals minus 3, and this is achieved by subtracting minus 3 from both sides. So it's working. So this fraction is undefined when x is minus 3. Let's test it. When x is minus 3, 1 over x plus 3 is what? Let's do that here. One over x plus 3 is equal to 1 over minus 3 plus 3, because x is now minus 3 in this case, which is 1 over what's minus 3 plus 3? Well, minus 3 plus 3 is same thing as 3 minus 3, which is 1 over 0. As you can see, when x is minus 3, the fraction has a non-zero numerator and a denominator that's equal to 0 when x is minus 3. So the value of x that causes the algebraic fraction, this fraction, to be undefined is minus 3. Here's another example question. For which value of y is the fraction below undefined? What value of y causes this fraction 2 over y minus 5 to be undefined? We know that for a fraction to be undefined, so the fraction a over b, the numerator must be non-zero and the denominator must be equal to 0. Now in this case, our numerator has a value of 2, so it's non-zero, so we pass this condition. The denominator has to be equal to 0, so we have here y minus 5. When is y minus 5 equal to 0? Well, y minus 5 is equal to 0 when y is equal to some value, which we can determine by simplifying this expression. So making y the subject of the formula can be achieved by adding 5 to both sides, which gives y minus 5 plus 5 equals to 0 plus 5. Minus 5 plus 5 is 0, so we have y equals 5. So when y is 5, this fraction becomes undefined. And let's test it. When y is 5, 2 over y minus 5 becomes 2 over 5 minus 5, which is 2 over 0. Numerator non-zero, denominator 0 when y is 5. So what value of y causes the fraction to be undefined? 5. When y is 5, this fraction is undefined. Here's another example. This is slightly more challenging than the ones we've seen. The example asks, the question is as follows: for what values of x is the fraction below undefined? Now remember, a fraction is undefined when its numerator, so for a fraction a over b, it's undefined when its numerator is not equal to 0. This numerator is not equal to 0. This numerator is 2. So we've satisfied this condition. And when its denominator is equal to 0. In this case, our denominator is x minus 3 times x plus 5. For this fraction to be undefined, this denominator term must be equal to 0. But remember, from a previous video, we've covered a scenario like this where you have the product of two variables. So this x minus 3 term is a variable, and this x plus 5 term itself is a variable. When you have the product of two variables equaling 0, the result is one of the following, or both of the following: that the first variable is equal to 0, or the second variable is equal to 0. A previous video has shown the procedure for solving such problems, so it's assumed that you understand what's going on here. If you don't, you have to go back. Now, for the case where the first variable is equal to 0, we have, by dropping the brackets, we have x minus 3 is 0. Adding 3 to both sides gives x equals 3. For the case where the second variable is equal to 0, dropping the brackets gives x plus 5 is equal to 0. And simplifying by subtracting, well, making x the subject of the formula by subtracting 5 from both sides gives x equals minus 5. So this fraction is undefined when x is 3, or when x is minus 5. Or I could say when x is 3 and also when x is minus 5. So these are the values of x. So the question asks for the values of x that causes this fraction to be undefined, and the values are 3 and minus 5. Here's a final example. So here we go. Determine the conditions for which the following fraction is undefined. As we know, for an algebraic fraction with a numerator a and a denominator b, such a fraction is undefined when the numerator is not equal to 0 and the denominator value is equal to 0. So let's start with the denominator. When is this denominator value equal to 0? When is denominator condition? The denominator value is equal to 0 when either x plus 6 is 0 or y minus 2 is equal to 0. When x plus 6 is 0, x plus 6 equals 0, x is equal to minus 6. This step is obtained by making x the subject of the formula in this expression. Y minus 2 equals 0 is the other situation, which we can simplify, but first let's drop the brackets to give y minus 2 equals 0. And making y the subject of the formula gives y is equal to 2. So what we have here is the following result. The denominator term is 0 when x is minus 6, and is also equal to 0 when y is minus 2. Now, the denominator is a product of two variables, as it stands here. The first variable is x plus 6, the second variable is y minus 2. So this is what we have here. And remember, when you have an equation that states that the product of two variables is equal to 0, the solution to that equation is given by 1, the scenario where the first variable equals 0, and the second scenario is when the second variable is equal to 0. So when the first variable is equal to 0, we have x plus 6 equals 0, which we simplify to give x equals minus 6. When the second variable is equal to 0, we have the situation where y minus 2 is equal to 0, which we simplify to give y is equal to 2. So we know that when x is equal to minus 6 and y is equal to 2, the denominator condition is satisfied. What about the numerator condition? The numerator condition requires that the numerator is not equal to 0. So as the numerator stands, we have the expression 3y plus 1 as the numerator. And this y is a variable, so it can take several values. We need to now find out which values of y are valid, which values of y are such that the numerator term is non-zero. An easy way to determine that is to determine the values or the value of y for which the numerator is equal to 0 first. Once we know that, we can then know which values cause the numerator to not be equal to 0. So let's just try the following. So the numerator is 3y plus 1. When is 3y plus 1 equal to 0? 3y plus 1 is equal to 0 when y is equal to some value, which you can determine by making y the subject of the formula of this equation. So subtracting 1 from both sides gives 3y equals minus 1. Dividing through by 3 gives y equals minus 1 over 3. So we know that the numerator is equal to 0 when y is equal to minus 1 over 3. But we want the numerator to not be equal to 0. When y is minus 1 over 3, the numerator is equal to 0. Therefore, when y is not equal to minus 1 over 3, the numerator is not equal to 0. So our result are as follows. The conditions for which the following fraction is undefined are as follows. X equals minus 6, y equals 2, and y is not equal to 1 over 3. So these are the conditions for the denominator of the given fraction to be equal to 0, and this is the condition for the numerator to be not equal to 0. So this here is the condition for a non-zero numerator, a numerator value that is not equal to 0. And remember, for an algebraic fraction, two conditions need to be met for the algebraic fraction to be undefined. A has to be non-zero, and that's the condition here, and the denominator b must be equal to 0. So the proper way to write the answer to this question is as follows. Now, when y is not equal to minus 1 over 3, the first condition is met. A is not equal to 0. So we have a numerator that's non-zero. Now, we also need a condition for a denominator that's equal to 0. When x is minus 6, the denominator is 0. And let's test it. So we have 3y plus 1 over x plus 6 times y minus 2. Now, when x is minus 6, this term, x plus 6, becomes minus 6 plus 6, which is the same thing as 6 minus 6, which is 0. 0 times y minus 2 is 0. So the denominator term is 0 when x is minus 6. So when y is not equal to minus 1 over 3 and x is equal to minus 6, this fraction is undefined. So this is one possible solution. Another solution is, again, the numerator is non-zero and y equals 2. When y is equal to 2, this term y minus 2 becomes 2 minus 2, which is 0. So we then have the denominator x plus 6 times 0, which gives 0. So the condition for a denominator value being equal to 0 is met when y is equal to 2. And we know that when y is not equal to minus 1 over 3, the numerator value is non-zero. So here's another condition. Another solution is to say, well, we want a non-zero numerator, so y not be equal to minus 1 over 3. And we can say that x is minus 6 and y is also 2. In this first case, we're saying y is not equal to minus 1 over 3, x is equal to minus 6, and y can take any value. Because regardless of what value y takes, when x is minus 6, this term goes to 0. This term becomes 0. No matter what y is, 0 times whatever that thing will be 0. Similarly, in the second case, we're saying y is equal to 2 and x can take any value. We didn't specify the value of x because when y is 2, this term becomes 0. Regardless of what x is, that term is going to be multiplied by 0 and it's going to give a denominator of 0. So that's why this is a separate solution from this. And the last case is saying x is minus 6, which means x plus 6 is 0, and y is also 2, which means this y minus 2 term is 0. So 0 times 0 is 0. So it's telling us the denominator term has a value of 0. And we know that when y is not equal to minus 1 over 3, the numerator is also 0. So these are 3 separate solutions which cause the given algebraic fraction to be undefined. So these are separate solutions.